This is the ARMEE vent. It's based on 1960s technology from the U.S. Army. That's where we found the patent and just went and built it and realized, oh wow, it actually works. So yeah, it's exactly what you see there, just on the right side picture. It is simply just a pressure control switch. Essentially, it's an airfoil. Essentially, all it does is just regulate the minimum and maximum pressure that will be output by the device to the patient. And it turns out that's basically a lot of what you need. If you're comfortable with a pressure controlled ventilator, that's the main component here. And there's, needs some sensors and other things, of course, to add some safety, but it does what it does. And it's just a fact of physics, really. So it was really fun just discovering that. And that's what happened with this year, really. We just printed it out and tried it out. So yeah, this is entirely pneumatic and air powered. You just use a high pressure air stream that comes in through the bottom there. And it provides a pressure assisted breathing for the patient, where they're able to actually intake a breath, and the device will basically breathe for them. It'll help with their breathing, essentially, if they and time it to their breaths. It also functions as a BiPAP. The plan for this was, March hit and we were all just shell shocked, and we came on here, and I think most people were doing 10 or 12-hour days, just at least just jumping on here, trying to do whatever they could. And we wanted to build something that would be as quick and cheap to manufacture as possible, something that we could just turn out millions of in a few weeks. And this is what we got. We may have taken a bit too long to actually get it out there, and we got beaten to the punch by a lot of other companies, and that's good. And we were thankful for that. That was the goal all along. But this was the backup. This is what we were worried that we might actually need en masse in the world within, a month or two. And here's what we did. These are the unsung heroes here. So we had basically 100+ contributors. I think we were one of the larger ventilator groups at the time. We were running 2 different channels, Project Pneumatic Ventilator and Project Oscillating Ventilator. We just set up the design doc and then went from there, and we were jumping on just any design. We were looking at a whole variety of pneumatic designs, and we basically found 6 different ones or something here. Some of the people that you guys probably don't hear about too much are Cedric, Jim, and Dan, especially, who each of them independently invented their own pneumatic ventilator. This is not even the 1960s one that we just pulled that somebody else invented. These guys invented them from scratch. So well done to them. And then Joshua also went ahead and completely re-engineered an existing market device and then made it even more manufacturable. And that's the what's it called, the Vortran go-to vent. And so that one was also just a thing to have in our back pocket, just in case it needed to be done. And hopefully between Joshua and Vortran themselves, they probably sent out millions of ventilators by now, hopefully too. So good on them. But we settled on one patent that was from the 1960s era. It just seemed something that was very achievable and something that we knew that we could just do, and that would be able to make hundreds of thousands in a short period of time if we needed to. So we spun off with some of the most active engineers on the channel. We had working prototypes within a week or two that were actually testing and pretty closely matching the curves that we were hoping to reach. As pressure curves for the patient. I want to say another big thank you to Zach Bloom, who made a lot of this happen by donating a $1,000 plus test lung. That was just wow, well done, wow. Right? And that got us so far. And also to Robert Reed and Public Invention for giving us the VentMon, which is an unsung, that thing is a beauty. It really did a lot. And then in May, we had some contacts where we managed to get in with the National Institute of Health and somehow actually piqued their interest enough to actually start testing on this. And it was a bit of an awkward thing with COVID restrictions and stuff. They couldn't even go to the office and whatever. So it was a lot of just Zoom meetings, but that relationship kept on for several months, and they have been testing the team until December of last year here. And they were even testing near the end on pig studies. They're actually just running it on live animals. I don't know the results of that because basically our team ended up splitting off into a private and public split here. I stayed on the public side. The other guys are on the private side. I don't really know what they're up to, but hopefully they're doing well still. I think that last time I checked, they were still pending the EUA FDA review and still testing with the NIH. So hopefully they have some success there. As for me, I've just been sticking around with a few other people on the open source side, just keeping it maintainable and helping anybody who comes along. We are still always looking for champions, anybody who wants to take this device and print it and give it a shot and wherever they think they can take it. If you think you can make it a marketable device again, like go for it.